All right, here we go for another great day in programming paradigms. And, and you're being recorded. Wasn't loud enough. Yeah, I've noticed that some people are intentionally a little bit louder and some people are intentionally a little bit quieter whenever we're doing the recordings. So anyway. But I think at the end of class last time, we had just started chapter 7 and we did, what did we do? Lists. And now, can you tell me, let's review this a little bit. What is the definition of a list? What's the first part of the definition of a list? Well, even before that. The base case. An empty list is a what? Is a list. An empty list is a list. And now you can do the car thing. And then a non-empty list has how many parts? Two. And what are they? Car and cooter. And car is the what? The first of the list. And it is an element. And the what? The cooter is the rest of the list. And it is a list. Now, had we done cons? Yes. Maybe, is that where we ended? Okay, so let's go to our demo and pick up where we left off. Okay, so here's our demo, and now just to review real quickly, let's do a car of quote A, B, C, D, and that's the A, and let's do the cooter of quote A, B, C, D, D, and what is this? Prediction? BCD. List BCD, right. Okay, and then we did a whole bunch of nesting and all that kind of stuff. Now, now the opposite of this is cons. And so, oh yeah, I think we did, now that I'm talking about, I do remember, we did a bunch of cons examples, didn't we? And we can cons. So here, let's do maybe one of those. What do you suppose happens if we cons, quote, A, B, C into, quote, D, E, F? Will that be the list A, B, C, D, E, F? Yes or no? Well, it'll be the list A, B, C into D, E, F, right? Because remember, the way it works is like this. If we cons, quote, if we cons, quote, A into the list B, C, D, then A is the, oh, I forgot to quote my list, sorry. Cons, quote, A into, quote, B, C, D, then A goes in as an element. And so if the list goes in as an element, then the first one is, the first element of the list that it goes into is itself a list. Is everybody clear on that? Let's run this and get rid of all that ugly red. Okay, now, check this out. What do you suppose then is this? If we do cons, quote, A into, quote, the list B, what do we get? The list AB. So what do you suppose happens if we do cons, quote, A into the empty list? The list A. Now, is everybody with me on that? All right. And what is the car of, quote, of the list A? What is the car of that? That's A. And what is the cooter? What is the, you already know what I'm going to do. What is the cooter of, quote, A, boom. And that is, what did you say? Empty list. You knew I was going to do that. But now what about this? What about the cooter of the empty list? Error. And what about the car of the empty list? Error. Also error. Are you with me? Is everybody clear? You can't, the car and the cooter. So how can we tell if we're going to do suppose you want to do a cooter or a car on a list. It will be an error if you do a cooter or a car on a list that is empty, right? So what do we need before we do a car or a cooter on a list? in order to ensure that it's not empty. We need a what? What do we need? We need an if statement with a predicate that will test what? And what will we say? If what? Well, it's called a null, N-U-L-L question mark. And so what happens is null question mark of this ABC is what, do you suppose? Is ABC the empty list? You're right, it's not. On the other hand, what happens if we do null the empty list? True. Is everybody with me? So this null is a predicate. Can you tell me now, sports fans? Do you remember what is a predicate? From your formal methods class, what's the definition of a predicate? Well, it's not a statement, but that was a proposition. The statement was the proposition that is either true or false. But what is a predicate? What paradigm are we in? It's a function that returns type Boolean. And do you see that null is a function that returns type Boolean? So it is a predicate. Are we good? Okay, so that's null. Now, so tell me, how would you build up the list ABC? If we cons quote C with the empty list, what do we get? We get the list C. But then what if we want to cons A to that? Well, we would cons what? We could cons quote A with the what? The cons of, the cons of B with the what? Cons of quote C with the empty list. And what would this be? The list BC, and we could cons, let's do one more just for fun. And if we cons quote A, because once we got this started, we can't stop, right? Cons A with the cons B with the what? Cons C, oops. Am I correct my errors here? Of what? The empty list, boom, boom, boom. And what is this? Obviously, ABC. Now, there is a shortcut because we don't want to have to do this all the time. And guess what the shortcut is called? It's called list. And look what you can do with list. This is so nice, so convenient. What can you do? Quote A, quote B, quote C. And what will it do? It will cons the A with the cons of B with the cons of C with the empty list, all for you automatically, and produce ABC. So, sports fans, what happens if we say list, quote, AB, quote, C, quote, D? A list with how many elements? 3, the first one of which is itself the list AB. So is everybody clear about that? Does everybody see how list works? It's a nice little built-in function that produces a list from a bunch of other things. But it's really just a shortcut for the cons of the cons of the cons with the empty list. Yeah? Is everybody good? Okay, so now let's start. Now that we have let's start all over here. Now that we have all these little tools to work with, now let's start writing some interesting functions with them. The first function we're going to try to write is integers from 2 that has this signature, lambda, low, high. So here's how it works. Let's do integers. Let's do integers from 2 and let's do 3, 7. Now, what do you suppose this is going to do? Can you tell by the name of the function? And so what will that list be?
3, 4, 5, 6.
Yeah, 3, 4, 5, 6, and 7. Does everybody see what that does? This is just a little exercise for us. There's 3, 2, and furthermore, what do you suppose happens if we do integers from 2, and now suppose we do something like 3, 2.
Error.
Well, it'll be the empty list. All right?
Is there a list comprehension method?
Well, I mean, the only thing we have to work with is what we've got, is what we've done so far. And what are the tools that we have to work with so far? Cons and car and coulter. And so how do we, now tell me, you guys, write this. We need to write integers from 2, lambda, low, high. So what's our base case? Low, well, huh?
Low is greater than high?
Yeah, if low is great, yeah, if low, actually, what would it be if they're equal? Here, let's try this. Let's do, here, actually, that's a good question. Integers from 2, let's do 7, 7. What should this do? A list with 7 in it. Oh, yeah, that was a good example. So now, so what's our base case?
Low equals high.
Well, I think it'd be less, well, or would it be,
Greater than high. Or if low equals high minus 1.
how about if greater than low, high? Now, what should get returned if greater than low, high, what gets returned? The empty list, okay? And so how do we write that? Now, our author always puts a quote in here. Let's, the same way that we put quotes in front of any list, it returns that list. But I usually just, the empty list evaluates to itself the same way that 3 evaluates to itself. Do you see what I mean? So I normally just don't. Our author likes to put the quote in front of the empty list, but you don't really need it, so I usually don't bother. Yeah, question?
Can you take the data that's in a list and have it evaluate later if you were to extract it?
Yes, you can. And we, in fact, will do just that. The question is, can you actually take a list and evaluate it as if the first one is a function? And that is an extremely important idea, and it's something that we're able to do. And do you know why we have to be able to do that? Because what is the ruling loop in this part in this interactive part? It's the what loop. Has three parts to it. Read, eval, print. What you just asked was the eval part. So there has to be a way, since Lisp is written in Lisp, it's a Lisp that's behind this controller, and so it has to have a way to eval the lists. So yeah, that was a good question. Okay, so now if low is this, so if greater than low, high, but now what if low is not greater than high? Then what do we do? Now it's going to have to be recursive. So can you write this? So what? We have to cons something. So what do we cons?
Low.
We cons low.
And for the rest parameter, you would put integers from 2, low minus 1, and high.
Would it be low minus 1 or would it be? Oh, wait a minute. Or wait, or is it high? Wait.
Low plus 1.
Low plus
Wait. Do we start at the high end or do we start at the low end?
Low and
Because every time you cons, what are you doing?
It's the first element and then the rest of the list.
So wouldn't you cons
We have to
integers
put-
from 2, low, high minus 1, and high?
do either way, right?
Could you do it either way?
Or base?
That way, then do it low, starting with low at that base case.
Oh, yeah.
Should we cons, I think, yeah, actually, well, I think we should cons starting from the, well, what is it that we, okay, here when we did integers from to 3, 7, what is the, we wanted to cons the 3 into the what? Into, yeah, we wanted to cons the 3 into what?
The rest.
Into the integers from, well, but there is no rest. Into the integers from 2 of what?
4 and 7.
Of 4 and 7. Yeah, okay, so yeah, is that what you said at the beginning?
Yeah, well,
Yeah.
low plus 1 and then high.
Do they need all those apostrophes in front of them every time?
Well, I just, this apostrophe is actually you don't need, but that's because of this special case of this, of the empty list evaluating to itself.
But when we add low to the list, we need apostrophe low.
No, low is an integer. We can't, no. Low is an integer and high are integer. Low and high are integers. Notice it's 3 and 7. There's no quotes there. Are you with me? No quotes. Okay, so here we go. So we're going to cons low. Okay, so here, so cons low with what?
Integers from
Integers from 2 of what?
+1 low.
Of +1 low and high. Good. Is everybody clear on how that worked? Are we good? Okay, now let's do another one. Let's start all over again. And let's do, there's one called, now there is a built-in function called length. Length, and you obviously, what is this obviously going to be? What's that going to be? 3, obviously. So what we're going to need to do is, anytime I ask you to rewrite a function that's already available, we'll prefix it with my. So this is my length. All right. And so my length obviously is going to return 3. Does everybody understand what we're doing? Because I'm asking, we're going to redefine a function that's already available, but that makes a good exercise. Right? Okay, and obviously what should my length of the empty list be? 0. Okay, so I think this is pretty straightforward. Someone want to take a stab at it? Define what? My length, lambda LST. So that's going to be our list. Oops. Oh, shoot. I just slipped. If null list, return what? Okay. Oh, darn. My thing is, it shows when okay, I'll have to get used to how it scrolls. I'm not used to the scrolling here. So if list is null, we return 0. Otherwise, what?
+1.
What about +1?
My list.
Okay, so say it again. It's going to be, wait.
My length.
Oh, yeah.
No, it's going to be, no, we have to plus first, right? Okay, so then what it would be?
+1 my length, cdr list.
Ah, +1 my length of the cdr of the list, right? Now, does everybody see how that worked? Are we good? I think I know why it's doing this. I think I need to scooch down a little bit more. Yes. Okay. Does everybody see how my length worked? Okay, now how about this? How about we do another one called sum? Now, and here's how sum's going to work. Sum, let's do sum 372. Oops, 372. Now, obviously, what should sum 372 be? 12. And so what are we doing? We're adding the sum of all the integers. We're adding the sum of the list of integers. All right? And obviously, what is sum of the empty list?
0.
Because it should be 0 because why? 0 is the identity for the addition operation. Okay. This should be pretty easy. Define what? Sum. Well, sum is not built in. I mean, what is built in is this, plus 3, 7, 2. But what is this adding? These individual numbers. But this sum is adding a list of integers. Do you see what I mean? Okay, so now, what do you think? What's the next line? Come on.
Lambda,
Lambda what?
list,
List. Okay, and now what?
if my line is 0.
What's, if null, that's how we tell if it's the empty list. Null, are you with me? So if null what?
Question mark,
If null list,
0,
0. Now what?
plus,
Plus the what? The car of the list with the sum of the cooter. Plus the car of the list with the sum of the cooter of the list. Now, is everybody clear on this? Are you with me? Is everybody good? This stack, once you sort of like get the hang of this, car and cooter and null, pretty soon everything just, you can see why, I can see why there's a big movement to teach this as the very first programming language. Because once you sort of get the hang of it, you learn recursion first before you learn loops. And then it makes recursion easy. Because do you remember having a little bit of a difficult time learning how recursion worked? Because we were immersed in that other paradigm, you know? But anyway,
I have a question.
sure.
When you do the addition thing,
Mhm.
with the plus sign, can you put as many numbers as you want?
You can, as we illustrated right here. See, so you could do plus 3, 7, 2, 4, 100, 9, whatever, okay? And so yes, you can.
Is it just with pluses and you do the same with like subtract both?
I'm pretty sure you can do the same thing with subtract. If you do minus 3, 4, 7, then, but now see, the thing of it is that subtract is not, it's not symmetric. In other words, a minus b is not the same thing as b minus a. So the question is this might be kind of hard to predict, because what will it do? Will it do 3 minus 4 minus 7? I mean, what it will subtract, I mean, negative 8. But I mean, it's not quite as clear. Okay, are we good? So now the next thing we wanted to look at is my filter. Now watch this, how my filter is going to work. Now obviously, because we're saying my filter, there is a what? Built-in what? There is a built-in filter. So let's define my filter, and what we're going to do is this is going to be odd, and then we're going to give, for the second parameter, we're going to give 2, 5, 9, 6, 12, 1. 2, 5, 9, 6, 12, 1. Now, can you tell from the name of my filter, or sorry, of my filter, it's odd, but it's my filter. What will my filter, odd, of 2, 5, 9, 6, 12, 1, do return?
Odd numbers?
Yeah, it will filter out all the ones that are not odd. So it will just give us the odd ones, which are 5, 9, and 1. And if I did this with filter, it would do the same thing. So how many parameters does filter have? 2. So when we say returns a list of the elements in LST that satisfy the predicate OK. So we're going to say define my filter, and now what? Lambda what?
Okay.
OK and list. Okay, so lambda OK list. And do we have a base case that we can illustrate here? What would the base case? My filter odd what? So if null list,
Return the empty bracket.
yeah, the empty list. Yeah, we return the empty list. And here again, you don't need the quote. Otherwise, oh, now, haha. What is the myFilter odd of 259.612.1? What do we have to do, you guys?
You would do odd car.
Yeah, only it's not odd because odd is the actual parameter and the formal parameter is what?
Okay.
Okay, so we have to check if what?
If the car
It is, passes the okay. Are you with me? And if it passes the okay, if the car of the list passes the okay test, what do we have to do? What do we return?
cons
We cons the what?
the car, that pass.
We cons the car with the what?
empty,
No, not with the empty list, but with the what?
myFilter.
With the,
car. If it passes.
with the, yeah, ooh, okay, I think we're on the right track.
Who comes the car with myFilter odd cooter?
Yeah, we cons the car with the myFilter of the cooter. Boy, is everybody following this? Okay, so the first test is okay, car list, and now what did you say we returned?
Cons,
The cons of the what?
car,
Of the car of the list with the what?
myFilter,
With the myFilter of
okay cooter.
okay of the cooter. So cons the car of list with the myFilter okay of the cooter of list. Is that just, I mean, isn't that slick? You just kind of like say it, and it just, the code writes itself once you kind of understand how the cons and car and the cooter work, right? But what if car doesn't pass? What if the car of the list doesn't pass that? Then what do you return?
Cons the empty list with myFilter, blah, blah, blah.
Close but no cigar. You don't cons the empty list.
My filter.
You just return the myFilter okay of the cooter. For one thing, the empty list is not an element. Are you with me? So you just don't cons the car of the list with it. You just return myFilter.
Isn't that what you're doing in the base case though? Because when myFilter okay reaches the base case, you're going to cons it with that empty list element.
Aha, but you see what's going on there is the reason that we return the empty list in that case is because the very first time we do something, like if we cons, what we will do is we will cons 1 with the empty list. And if we cons 1 with the empty list, that's how we get started. So we're still consing, this 1 will still be the, I don't know how to say this. Did this answer your question or no?
So you can cons them with an empty list, but you don't need to unless it's like the first element.
Well, no, this is not the same thing. Well, here, wait, before we continue this discussion, else what?
MyFilter stuff.
Yes, else myFilter, okay, cooter of the list. Now, your question is, oh, actually, we didn't dwell on this too much. This is a condition. So when we have this else, we're doing a condition. We're not using nested ifs. But anyway. But now, what was your question? Because see, I think what you wanted to do here was cons the empty list. See, look, this doesn't, hold on. Oh, I think I know how I can explain this. Watch this. What do you suppose happens if we cons the empty list with the quote A, B, C? Does anybody know what this is going to be? Can anybody predict this? Maybe this will answer your question.
Yeah, I think it will.
Do you think it'll be ABC?
I would think ABC.
I think it's the empty list in front of.
It's not ABC. Man, that's going to be the answer to your question. Watch this. Drum roll. It's the empty list ABC. You were right. And that is not what we want. Yeah, so maybe that's the answer to your question. Is everybody good on this? If you take the, that's easy. What if you take the car of the quote, empty list A, B, C? No, what is can you predict, can you answer your own question? Yeah, why not? Yeah, this was a good demo. That was a good question. So yeah, you were thinking that consing the empty list would be nothing, but the empty list isn't nothing, it's something. It is the empty list. Yeah, the empty list isn't nothing.
So there's a special case when you cons the empty list in one element.
Well, remember when you
Or it's a
cons,
list in an element, not a list in a list.
well, think of the cons as being, of consing an element.
Can you cons two?
Because look, I know how, hold on. Check this out. Let's cons this. Oops, wait. Let's cons this with this. Okay, now do you understand what this is going to be? Can you predict what this is going to be?
List A, B, C, D.
Yes. And so consequently, if you cons just this with, do you see that this is consistent?
Yeah.
Did that answer your question?
Yeah. If you cons
If
two
you-
empty lists.
Good question. Good question. That's a good one. This would be a good one for this would be a good first question on the next exam. What do you suppose would happen here?
Two empty lists.
Yes.
Oh, that's weird.
But no, it works, right?
Yeah.
Is it not? I should have done this on the first, I should have done this last time. This is a good demo. Does everybody see how that worked? If you cons the empty list with the empty list goes into the first element of the empty list. By the way, now that we've done this, what do you suppose? What do you suppose happens if we do null, the empty? What happens here? Well, what do you think about this?
False.
Yeah. Oops. Oh, did I have the wrong number of parens? Wait. Oh, maybe this time I need a quote. You're right. This time I need a quote.
We have a question mark.
Oh, yeah. Thanks. No. Yeah, this time I need the quote. I'm getting sloppy with my note. No wonder the author always puts quotes in there. Okay, so now what is this going to be? Yeah. Because the first element, because that list has an element in it, namely the empty list. Yeah. Oh, this was a good demo. You guys are asking really good questions. All right. Now, how about first element of? Check this out. First element of, elements. First elements of, now let's do A, B, C, D, E, F, G. Only now what we have to say is, oops, we have to say first elements of, and we have to say how many. So, you guys, what do you suppose this is going to be? First elements of? The list ABC. All right? And what do you suppose happens if we are a little stingy and we do first elements of, and we say 3, but we only give them A, B? What do you suppose is going to happen here? Yeah, this is going to be an error. Oh, rats, and by showing me the error, it showed the code. Darn, don't look, don't look, don't look. Okay, now you can look. All right. Now, so returns the first n elements of LST. So now, what's going to be the base case here? Let's do the base case. First elements of, and now what's going to be the base case like? Huh? Yeah, I think 0. You're right. I think it's 0 of A, B, C. And what will that be? The empty list, right. Okay. So, define first elements. So what'll happen here?
Lambda n.
Lambda,
List.
n, and list. Yeah, there are 2 parameters. Good. Then what? Oops.
If equals
N
n
0. That's right. If equals n 0.
Which is empty.
That's right. So there's the empty list. Otherwise, what do we return? Ah, now what do we return? We have to cons, we have to construct, oh well, is it?
Yeah,
Yeah.
Do we do a cons?
is there a remove element from this function? Otherwise, we would need to. Yeah.
No, well, we have the coulter is the, what is the, actually here, maybe we should get the other one back on the screen. Let's do, it was first elements of, let's think about this a little bit. And then we had 3, and then what do we have? Quote, like A, B, C, D, E, F, G. And that was A, B, C. So what is, we have to cons, oh yeah, what do we cons? The car of the list with the what?
First elements of
With the first elements of is right, of the what? Minus n1 of the coulter. Oh man, you guys are good. You can just say it, and then you just type what you were going to say, and it works. Is this good? So look, let's come up here. Let's reveal this. So we're going to cons the car of the list with the what? First elements of the what? Minus n1. The first elements of the minus n1 of the what? Of the coulter of the list. Right? Is everybody good? Excellent. Okay. Now, there is a built-in tail function that I want to show you now. Because this is how we get the first, we have to write first elements of, but now there is a built-in tail function. Now, this one's built in. It's called list tail. But it's not quite obvious what it's going to return. So you're probably going to be wrong if you guess this. Let's do A, B, C, D, E, F, G, H. And now this time the count is on the other end. It's 3. So the count is is the second parameter instead of being the first parameter like it was in first elements up. Does anyone want to take a stab at this?
FGH.
Yeah, that's what you would think, huh? Huh?
HGF.
Oh, no, it doesn't reverse the order.
DAH.
You're just kind of doing things at random. No, check it out. See, that's kind of not intuitive, but what does it do? And when you say list tail, it does what? It's the tail after you have removed the first three. Do you see what I'm saying? That's how list tail works. Okay, and that one's built in. All right.
Have a list size 3 and the number is 7, or something like that.
Oh, that's a good question. Let's experiment. List tail. So if we just have like quote A, B, C, let's make it D, but then we say all but we have put a big number here like 7. Is that what you're asking? This might be an error. It'd either be an error or what? What would be a reasonable thing? Yeah, too large. Yeah, so it is an error. Okay, so now, so that's list tail. Now we're going to do one more. Now watch this. This next one is called interleave. This will require a little thinking, but it sounds like you're with me on this. A, B, C.
This was like that problem in data structures that was really hard.
Yes. In fact, that problem in data structures that was really hard, watch this. Watch this. What do you suppose this is going to return?
A, D, B, E, C, F.
Correct. A, B, A, D, B, E, C, F. I think we called this zip.
Yeah.
A, D, B, E, C, F. And furthermore, it starts with the what? It starts with which one? It starts with the first letter of the first element of the first list. Are you with me? Now let's do a couple of other ones just to show what happens if the lists are unbalanced. If we do interleave, quote, now let's do A, B, C, D, E, F here, and quote GHI, or we could use numbers, but let's do GHI. Okay, now what do you suppose it's going to be? Now can you predict this? Yes, yes. A, G, B, H, C, I, and then what? D, E, F. So that's fine to have them not be the same length. And it works the other way around. Interleave, quote, and then let's do A, B, C, and then quote, D, E, F, G, H, I. Okay, and what will this be? A, D, B, E, C, F, and then G, H, I. Oops, needed an extra paren. A, D, B, E, C, F, and then G, H, I. Is everybody clear on this?
What if you do it with an empty?
What is going to be the base case? If we interleave the empty list with A, B, C, D, then what's going to happen? A, B, C, D. But which one is going to be the base case? Because if we do interleave, quote, A, B, C, D with the empty list, then that's also A, B, C, D, just like we would expect. But now, what's the deal with interleave? Well, this is, and it starts with how are we going to do this? Okay, check this out, sports fans. Let's go to our slides here. So look, here's the question is, how are we going to write interleave? So if we interleave A, B, C, and D, E, F, what do we start with?
That guy.
The car of the first one. Are you with me? Is everybody with me on this? So does everybody see that the car of A, B, C is the A? Yeah? And what's the cooter of A, B, C? What's the cooter of A, B, C? That's the BC. Is everybody with me so far? That's the BC. Well, tell me, what's going to be the recursive one? Yeah, something's going to be flipped here. So what's going to be D? Yeah, what we need to, if we interleave DEF with the what? With the cooter of the first one. So look, if we interleave DEF with the cooter of the first one, what do we get? D, B, E, C, F, right? Are you with me? Is everybody clear on this? Okay. So as all we have to do to this is to get what we want to be the original interleave, is all we have to do with this is do what? Yes, cons the car of the first one with it. So look, is all we have to do is cons that one in there. And we got it. Does everybody see how that worked? To interleave A, B, C, and D, E, F, well, think about it. The car of ABC is A. The cooter of ABC is BC. So if we interleave the DEF with the BC, what we get is DBECF. And all we have to do is, so the code just writes itself. So now what's the base case? If the, well, I don't think they both have to be null, do they?
If the first one's null, return the second one.
If the first, yes, because actually that's a good point. Look, do you see that in order to make progress towards our goal, what do we have to do? We have to take the car of the first list and the cooter of the first list. So do you see then that the base case is, but you can't take the car of the first list and the cooter of the first list if the first list is what?
No.
Is empty, right. Yeah, if the first list is empty. So that's going to be, so that guard will make sure that there is a car and there is a cooter. But you see, this whole thing works even if DEF is empty, you know. All right, so let's go back to our demo. So you guys, what is it? Here, let's go. What is it? Define interleave. And now it's going to be define interleave. And what are we going to have? Next line? Lambda what?
List 1, list 2.
Lambda, list 1, list 2. And it interleaves this one, list 2, starting with the first element of list 1, if any. So what's our test? If null list 1. What do we return? List 2. Yeah? Otherwise, what do we know? What do we know? Otherwise, what do we know about list 1? It has a what? It has a car and a cooter because we know it's not empty. Is everybody with me? See how this works? The guard, I mean, you check to see if it's not empty. If it's not empty, then you can take its car and its cooter. That's always how you think about this. Okay, so now what? So you cons the what? The car of list 1 with the what? With the interleave. So you cons the car of list 1 with the what? With the interleave of list 2 and the cooter of list 1, and you're done. Now I ask you, you remember how hard it was to do in the data structures with C++? And why is that? That's because the cons and the car and the cooter it's that built in. It is the numero uno data type that is in Lisp. You see? And you see how this is, I mean, look, what we're doing is we're processing symbols. This is symbol processing. This is why this is one of the lingua francas of artificial intelligence. It's because we're doing symbol processing. And what are symbols? They're just lists. See? You know, like language. Natural language is a list of letters. Yeah? Symbols. We're not doing arithmetic so much as we're doing symbol list manipulation. Yeah, good deal. All right. So, See you next time.